are recording. Hello, welcome to our little math classroom that has been, it's going what, 4 months now? 5 months?
Sure.
I don't know. I just want to go back to school. That's the honest truth. But it's looking hopeful. Vaccines are out. So we have a guest with us today, Miss Sanchez. Would you like to introduce yourself?
I'm Beth Sanchez. I'm one of the math teachers at Blair. I'm also the Student Service Learning Coordinator and the Academy Coordinator at Blair. So I wear a couple different hats.
Ooh, so can you kind of talk on those other roles?
So the Student Service Learning Coordinator, there's only one for all of Blair. So whenever you complete your Student Service Learning and you turn in your verification forms, I am the person who handles all of that paperwork. I also organize some SSL opportunities for seniors in particular to help them meet those graduation requirements and just kind of maintain and keep Blair aware of some of the opportunities happening in Montgomery County for volunteering. Oh, and then the Academy Coordinator, there are 5 career academies at Blair. Each one has a lead teacher, and we're fortunate at Blair that the lead teachers have been doing it for a long time, so they've got a ton of connections. Like Mr. Haig is our STEM Academy Coordinator, and he has connections at the FDA and NIH and UMD, and so he helps students get internships or different types of opportunities to explore different career fields in STEM. And it's the same for our other career academies as well. We have music, media and the arts, international studies and law, human service professions, and entrepreneurship and business management. So I kind of help them out and oversee and provide resources for whatever the academies need.
Awesome.
Mm-hmm.
More importantly, what is your favorite pizza topping?
It's pretty boring. It's mushrooms, and it kind of always has been, which as an adult, I think that I'm just so in the habit of saying mushrooms that I say mushrooms even though they don't provide a whole lot of flavor, but it's always been mushrooms.
Oh, I feel like mushrooms do provide flavor.
But not as much as some of the other, like now there's so many pizza toppings.
That's true.
Right?
There's this pizza place that has like chicken tikka pizza, and it's great. Like,
yeah.
So good. It's nice.
And I would say Frankly Pizza is my favorite local pizza. If you haven't had Frankly's, you should try it.
Frankly? F-R-A-N-K-L-E-E?
L-Y. It's
L-Y?
in Kensington.
Kensington? I'm going to have to check that out.
It's really good, and they're like small batch pizza. So right now they're only doing orders, but they do like a limited number of orders in the evening. Like it's a small operation, but it's really good.
I'm always looking for a new pizza place that does it right.
Yeah, they're really good.
This just popped into my head.
Well, you mentioned that it's only that's your favorite local, but do you have like a favorite not local? Because I hear that you're not from around here.
I am not from here. I am from Pittsburgh. And so at home where I grew up, Sir Pizza is like the best pizza. So that's kind of like my all-time go-to.
What's your favorite football team?
Steelers, obviously.
Well, I have some football fans, so they'll get a kick out of that.
Yeah.
I got one last question for you.
Yeah.
Actually, not one last question, 2 more questions. One question popped into my head a while ago, and I wanted to ask it. Is a hot dog a sandwich?
So I have been told that all food can fit into 3 categories: soup, salad, and sandwich. And so if you go by those classifications, a hot dog is a sandwich.
So what about like
take.
lo mein?
So lo mein would be a salad based on the classifications I was told about.
I strongly disagree.
Well,
that can be a good...
You can't make it a soup and you can't make it a sandwich. And a salad is like a bunch of things thrown in to a bowl or something like that. I don't know.
Mm-hmm.
I'm not great about what the classifications are. I just know those are...
You know they exist.
Those are the 3.
It's an existence theorem.
Is it? Cringe. I'm not vibing with that.
You don't like that joke? And the other question was, if a student were to need to reach out to you, what would be the best way to do that?
So I host SSL office hours on Wednesdays at 11:15, and on Blair's website, you can link up to the SSL website. And so I post opportunities there. The forms you need to fill in are there. I mean, you can always just email me if you have a question, but if you want to pop in and like talk about opportunities or catch up about SSL stuff, I host a Wednesday check-in at 11:15.
Or if you want to come in and get really angry about lo mein being a salad. They're coming
I know
for
where
you.
I'm going to be on Wednesday.
Awesome. Thank you so much. Is there anything else you want to share with us, or any words of wisdom? We usually end videos with words of wisdom.
Oh
They
my
don't
gosh.
have to be that wise.
My words of wisdom would be check the bag. Be prepared.
That doesn't make sense to me, but it sounds
The
profound.
night before, right? Like anytime you're getting ready to go anywhere or do anything, like check the bag.
Check the
Be
bag.
ready.
All right.
Check the bag.
Make sure you're ready the night before. Check the bag. I like that. That's a really good mantra. All right, thank you for
my
coming.
brain was at like zombies, and I was like, oh my gosh, what? Like, be prepared for what?
Anything.
Awesome. Thank you so much for coming. Do you
Thanks
want to
for
stick
having
around
me,
and do some
guys.
math? Or you good?
I have more meetings.
You go do what you got to do.
All right.
Ms. Sanchez is a busy person, everyone.
Bye, everybody.
Thanks
Thank
for
you.
coming.
All right, let's do some math.
Let's do it.
Let's do it. Let's do it. Let's do it. Isn't that Black Eyed Peas song?
Yeah, actually,
You
yesterday I was listening to a bunch of like old music because I guess Black Eyed Peas is now old. But I was listening to old music because recently just like really wanted to play Just Dance, but I don't have like the system. So then just watch YouTube videos of people playing Just Dance. Like,
and did you just dance along?
Yeah, it was fun.
That's a life. All right, let's get started. We have a goal of making these videos not too long. Hopefully everyone learned a little bit about Ms. Sanchez, what she does, and jump into her meetings on Wednesdays to get more SSL information.
And debate about hot dogs, and also give her a hard time about being a Steelers fan, because
right.
Sheesh, who does that?
All right, today it's a short one. We're trying to keep these, once again, videos a little bit shorter. We got 2 pages instead of 4. We are taking the graphs that we know how to graph now and doing what we did in reverse. We're getting the rule based on the graph. But there was a thing I said at the last video, and that was sine graphs and cosine graphs are basically, sorry, I had to fix something on my computer. Sine graphs and cosine graphs are basically the same thing shifted. What's that going to do? What kind of problem is that going to introduce, Mrs. Contreras?
Well, it's kind of like I like to think of it like we have different forms of like what a line is, right? But then it's all still the same graph. There's just different ways of showing it. But the issue is with like all these periodic things that there's more than just like, point slope form and slope intercept form and standard form, because we have a sine graph that like isn't that just like starts going up and then goes down. We have a cosine graph that starts going down, but then we have the reflections of all of those as well. So there's a lot of different options. And when we're shifting things, like if we're moving where the period starts, then we can shift to the left, we can shift to the right. There's just so many different options.
What I like to think about is I ask the students, look at this, then ask yourself. Self. What does your soul think this graph is? Is it a sine graph? Is it a cosine graph? Is it a negative sine graph, a reflected sine graph? Is it a negative cosine graph? Mrs. Contreras, look at this graph. What does your soul say it is?
I think it looks like a sine graph.
So do I. Yeah.
Yeah.
And you know what? I would argue that most people look at this and think sine graph. Why is that?
Well, because where it's starting on the y-axis, on the vertical axis, is the middle of it's on the midline.
And I could use the dotted line tool, but I'm not going to in this case. Yeah, I totally agree. There is no shift, no phase shift if we look at this as a sine graph. But if it's a positive cosine graph, where would that start?
That would start at pi over 6. Shift it over a little bit.
Pi over 6.
Or I guess like negative pi over, what is that? Negative pi over 3. So then 2 of those. It's negative 2 pi over 3? No.
Negative 2 pi over 3. What are we looking at?
On the
A
left
negative
side.
sign graph?
A negative sign graph. I was thinking I was thinking another option for a positive cosine graph.
Over here?
But I think I'm doing fractions wrong, which is okay.
We got pi over
Yeah.
6, negative pi over 2 pi over 6, negative 3 pi over 6. So it'd be negative pi over 2, right?
Yes.
Negative pi over 2. I like to do that. I like to add up the numerators and then at the end simplify my fraction.
Clever.
Negative 3 pi over 6. How about where would a negative sign graph be?
Negative sign graph would be at negative pi over 3 or at positive pi over 3.
Boom. And then what are we missing?
We're missing a negative cosine graph.
Let's go with purple. Negative cosine. And that's going to be halfway between pi over 3 and 2 pi over 3?
Yes. And also at negative pi over 6.
Well, I almost like that one better. But I'll get both. So we have all these different graphs. And what we need to do is establish their phase shift so we can write all 4. Then pick a favorite and then do something else with them. But we'll get to that in a second. What are these phase shifts? You've already told me, but let's get them written down. Doing a little bit of color coding here. What was the phase shift for my positive sign, my blue graph?
Yes.
Blue dot.
0.
Zero,
There's
right.
a 0 phase shift.
0. I guess I'll do phase shift equals 0, kind of like some weird notation going on over here, but I think that'll be fine. How about the positive cosine?
Positive cosine is a positive pi over 6.
Positive pi over 6. Now let's not forget that when we plug it into the form, it's going to have a negative sign. How about our negative sign?
Negative sign is the pi over 3 or the negative pi over 3.
Pi over 3, yep. And then finally,
Oh, I think you have pi over 6.
oh, let me fix that. Thank you. And then finally, last and least, the purple graph. Last but not least.
Well, I guess it is least because the starting point is like the
That's true,
furthest
yeah.
down. But yeah, pi over 2, right?
Yeah, I said that and I was hoping it would be received and it wasn't, but then it was received. I felt kind of bad. I was like, that was kind of mean. Pi over 2, awesome. And we could have done what? Negative or negative pi over 6.
Oh,
We could have done ors for all of these, but it doesn't really matter. All right, so in order to get the graphs, we need amplitude, period, vertical shift, and phase shift. We got the phase shift. We did all the heavy lifting already. What are the amplitude, period, and vertical shift of these graphs? Walk me
The
through.
amplitude, so our midline is at negative 1. So that gives us our vertical shift, actually. It's negative 1. And then going up to like the top of the mountain from negative 1 to 3 halves is going to be what, 5 halves?
3 halves. Yeah, 3 halves plus 1, 5 halves. Cool.
And then the period.
I think the trick would be like the peak minus the midline, which gets us 5 halves. Make a formula for it. And the period, sorry?
The period is going to be 2 pi over 3 is one complete cycle.
Where did your brain go to get that?
I went from the blue dot and then I looked to where I needed to, how far I need to go to the right in order to get a whole cycle to go.
Yeah,
And
not just half a cycle. Not when is the next time we're getting to negative 1, but when do we go up and down and then back up?
I guess you could take that and just double it.
That's true.
The first intersection and then double.
And we could have used any pair of points: red, red, green, green, blue, blue, purple, purple. But blue, I think I agree, was probably the easiest one to look at. Hence why our soul is saying that this is a positive sign graph. Let's.
But if you see it differently, it's okay, right?
Yeah.
Like it's okay.
All right, so I'm gonna do something. I'm gonna do this like assembly line style. I'm gonna write sine, sine, cosine, cosine. Put a negative there. Put a negative there. Parentheses. Parentheses. And then I'm not gonna put a plus over there yet, but I am gonna put an X here. Where do I put all these numbers?
Well, the vertical shift is like the last thing that we do. So we can put that outside of all of the trig, right? It's -1.
Mhm.
The amplitude is going to be the coefficient for our trig. So it's like the second to last thing that we do before we trig things. And then the period, and I always forget this. How do we figure out what our coefficient is going to be when we're looking at like changing the period from 2 pi?
Well, do you remember last time in the previous video when we wanted to get the period given the number? What did we do?
Was it like 2 pi over something?
2 pi over that number that we were given is equal to the period.
Oh, so then we just plug in the period for the p, and then
Yeah.
we'll find b.
Yeah.
Okay. Cool.
And if you want to get an equation for b given the period, you just do a little bit of algebra, and it's the exact same formula, right? Because there's an inverse relationship here between b and p. So if you just multiply both sides by 1 over p, multiply both sides by b, it's always 2 pi divided by the thing I give you. It's kind of convenient.
Yeah.
But that's annoying to memorize, so I just like to think about this formula.
Cool.
All right, so what is 2 pi over 3 divided by... No, I did that wrong. What is 2 pi
over
divided
2
by?
pi over 3?
Yeah. I think that's going to be 3, right?
Yeah, I think so.
Yeah. The 2 pi's are going to cancel. I have a 1 over 3 equals 3. So just stick a 3 here. And then now if you need to check your work, 2 pi divided by 3, oh, that gives me the thing. And then last, but not least, what am I going to put inside of all these parentheses?
The phase shift? I'm wondering if the parentheses are where we want them to be. Like,
No,
do we
they're
want
totally
the X
not.
on the
They're
inside
totally
of the
not.
parentheses? Okay. Because otherwise we're just multiplying everything.
Yeah. Thanks for
not
catching that.
super
Boom, 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 boom. How about
You're
that?
just so confident that I didn't
I
want
know.
to stop you. All right.
So
then we can look at what we had done already, because we did some of this work already.
Yeah.
Just scroll up a little bit.
So 0. Now we got to make sure that we're putting these in the right spot. So blue is my positive sign. That's -0. Or I'm just going to leave it blank. And the negative sign is Kermit the Frog green, pi over 3. Positive cosine is Elmo red. It's positive pi over 6. So minus pi over 6. And then negative cosine, that's purple. Are there any Muppets or Sesame Street characters that are purple?
The guy who has the collar, what's his name?
The collar? Are you talking about like the Dudley? Deadly?
I don't know.
Dudley? I don't know. Mary Kate, are there any Kermit the Frog? Are there any Muppet characters that are purple? Telly Monster. Telly Monster is pretty purple, I've been told. And the Honkers.
Oh yeah.
We got a resident Muppet fan over here. So Telly Monster purple minus pi over 2. Cool. All right, so we have now 4 functions, all of which can help us address the next question. Identify all values of x such that y is equal to 0.
So do we need to solve all of those?
I don't think so, right? Because they're all identical.
Oh, true.
Getting that word identity back. We could prove that 5 halves sine 3x minus 1 is congruent to negative 5 halves sine 3x minus pi over 3 minus 1, etc. Using some fancy tricks. No, we don't need to use it. Which one do you want to
Fancy.
use?
Fancy trigs.
Which one do you want to use?
The first one.
I
Because
totally
there's
agree.
No phase shift.
I totally agree. That's why it's important to ask yourself, what does my soul think this graph is? Because that is the graph that you should use to solve when this is equal to 0. And it looks like it's going to be equal to 0 at a really obnoxious spot. I'm just like highlighting the x-axis, so that's not very exciting. But we need to figure out when it's equal to 0. We need all of these answers. It doesn't say when is it equal to 0. What for what x value is it equal to 0 closest to the y-axis? It's asking for all of them. All values.
Do we need like a 2K pi?
There's going to be like a 2K pi at the end. But wait, there's not going to be a 2K pi though. Why is that?
Oh, because it's not periodic in that sense, right? Because it's like closer than.
Yeah, there's going to be a plus 2 pi over 3K. Because once I get this answer, I can get this answer very easily by adding 2 pi over 3K. Once I get this answer, I can easily get the next one by adding plus 2 pi over 3K. Likewise, I can get this one by subtracting 2 pi over 3K. So all I really need is 2 of the infinite answers, 2 that are not 2 pi over 3 apart. I don't want 2 of the same in the same subset. We need to figure these out. How do you figure out when a graph intersects another graph?
Set them equal to each other.
Set them equal. Let's set our favorite graph, 5 halves sine 3x minus 1 equal to 0. This is going to get kind of nasty.
Is it? Just like move the 1 over.
Move the 1 over, okay. So 5 halves sine 3x is equal to 1.
And then multiply by the reciprocal of our coefficient. So we get 2/5.
2/5. Not 2/3, 2/5.
And then what do we do?
So we did a problem in the previous lesson. Sine of x is equal to 0.8.
Oh.
That's just like 4/5. This is 2/5. What do we do to resolve this?
We use the function in the calculator. That's the inverse of sine functions, arc sine.
Yep, and let's see if I can get my calculator up. Here it comes.
Alt tab.
Yeah, but while I wait for my TI to pop up, what do I do with this 3x? I want you to think way back to like the second lesson of the year, maybe the third or fourth. When we were given factoring problems that had weird things in it. It starts with a U and ends with an substitution.
U substitution.
U substitution. The 3x is kind of weird. What I want to do is I want to, on the side here, right? U is equal to 3x. And then I want to solve sine U is equal to 2/5. That's the problem that we did over here. Then I want to sub that 3x back in a second. Right? And you don't actually have to do this U thing right here, but I think it's going to be beneficial dealing with this 3x, at least for the first time we ever do this. So I got my calculator up. That was also me just stalling to get a calculator. Here it is. So we need to figure out when does sine equal 2/5. That's the wrong tab.
Okay.
That's the right tab.
Okay.
So you were saying second sine?
Mm-hmm. For arc
and
sine.
Then 2 divided by 5. And then let me just double check them in the right mode. Radian.
Super
perfect.
rad.
Enter. 0.411. 0.411. Let me go ahead and drag that over. 0.411. But that happens every 2 pi.
Over 3.
Well, not yet.
Oh, because it's U.
Because we have the U is equal to 3x.
So then can we sub back in the 3x?
Yeah, we can sub back in. But before we do that, there's another place that we need to recognize. Where else on the unit circle is our y value 2/5?
Would it be pi minus that number?
Pi minus that number. So 3, I'm going to write pi. I'm not going to write 3.14. Pi minus 0.411. What is that? I'm going to figure it out real quick. Pi minus answer. 2.730. 2.730. All right, but now I want to do exactly what you said. Let's substitute back in. 3x is equal to these two numbers. (2.730) plus 2 pi k. And then what is your, what do you want to do?
Divide by 3.
Divide by 3 on both sides. Divide both of my solutions there by 3. And then we're going to get something.
Something.
Yeah, what might have been better for us to do than writing out all these decimals?
Theta, and then declaring what theta is.
We could have written theta and declared what theta was. I was thinking we could have just written sine inverse of 2/5 this entire time.
Oh, yeah.
We got 0.137 and...
Are you trying to show your calculator, or is it?
Not necessarily. I was just getting the answers. 910. Plus, we are also dividing the 2 pi k by 3. Hence that 2 pi over 3 that we talked about at the beginning. Just for those who do want to see the calculator, here's what I did. We got 0.411. We got the other answer, pi minus 0.411. And then I divided those two things by 3. If we go up here, we have 0.137 and 0.9. So 0.1 is right there, and 0.9 is right there. If we add the 2 pi 3, we get to the next one. If we subtract the 2 pi 3, we go backwards.
Real quick for a calculator thing.
Mm-hmm.
Could you go back to the calculator?
Yeah. Oh, I gotta do Alt Tab. Boom.
Nice. If you're trying to like divide something that was the answer, do you plug in all of that previous answer, or do you use a function in the calculator?
What I do, if I had typed this in that fast, I would have been really impressed with myself. I just hit the up button.
Oh, cool. I didn't know you
and
could do
then
that.
and then I hit enter, and then it populates it down there. Then you divide by 3. Boom.
Is there, because there's a way to do that even if you don't have the up button to like get there, right?
I think you can hit second, the negative sign, which does answer. This does the previous answer. So if I hit enter, I'm going to get 0.9. 0.9.
Nice.
Good stuff. Cool. Let me drag that instead of minimize. There we go. So that was a lot of effort to find out when we are equal to 0, but we were equal to 0 at a weird spot. It wasn't at a nice -1 or 3/2. We had to do some work to get the answer that we wanted. I feel like there's a life lesson there.
I think that was something that came up a lot, was being like just having persistence and perseverance, but also knowing when to ask for help. I think that's also a very valuable thing that a lot of our
very
students
common
learn.
theme this year.
Yeah.
All right. We got one other thing we want to do here. Hopefully it won't take too long. So we have two types of problems today. We have given a graph, do some stuff with it. And then given a scenario, let's produce a graph and then do pretty much the exact same process. Extrapolate data from that graph. That's essentially what we did up here in like a very laboratory kind of setting. Here it's a little bit more experimental. So would you be so kind in your thespian voice to read us this scenario?
I'm trying to think if I can do a Maryland accent, and I don't know if I can. In Ocean City, Maryland, the water is 8 feet deep. At the first high tide, which occurs at 4 a.m., low tide occurs 7.5 hours later, where the water has a depth of 18 inches. Part A, sketch and label a graph showing the depth of the water as a function of time in hours after 12 a.m., which is midnight.
And then let me go down so we can kind of keep the end goal in mind.
Kate's mom will not let her play in the water if the depth of the water exceeds 30 inches. Determine the times during the late morning and early afternoon that Kate can play in the water, because Kate's probably not going to be playing in the water at like midnight.
Exactly, yeah. I just imagine like a parent on the beach with a pencil and a pad and just, you can't play right now. A little bit convoluted, but I mean, you know, the people calculate the tides every single day, so you don't have to do the math. Someone else is doing the math for you, but we're gonna do the math here. We got to decide some stuff. We are working with units now. What units do you want to use? Well, I think it's actually telling us what we have to use.
Time in hours. So that's
time in hours.
T's hours. And then our problem is looking like our part B was looking for height in inches. So I guess we could just do everything in inches on the vertical axis.
That sounds good to me. Yeah, so we'll have inches here, and we'll have what do we say, hours here. Now, just to like provide this problem with some context, we're dealing with tides. So tides go up and down. They go up and down because the moon is exerting a gravitational pull on the Earth, but when it goes to the other side of the Earth, it's pulling it in a different way. So we do have a sinusoidal behavior here. So while it might not be perfectly sinusoidal, if we have a bunch of data points, you can fit a sine graph to it. So that's kind of what we're going to do here. We're going to model the scenario of the tides moving up and down with a sinusoid. Whether that ends up being cosine or sine, that's not the question yet. We're just going to use this curve that kind of emulates the tides going up and down. All right, so what else can we stick on this graph? Sorry?
Yeah, we can plot some points, right?
Mm-hmm.
Like first high tide occurs at 4 a.m. So
4
should we start like, since we're looking at hours after 12 a.m., then 4 a.m. is 4, because 12 a.m. is 0.
Yeah.
Hour 0. So then we have 4, and then 8 times 12 is 90.
Do you want to do feet instead of inches?
I don't know. Because 30 inches is how many feet? Like there's going to be a conversion. Oh, okay, there you go.
So what do you want to do, inches or feet?
I think we should do feet.
Okay, let's do feet. I'm on board with feet. All right, so what are we at it for, though?
4, 8.
8. So 1, 2, 3, 4, 5, 6, 7. And that's high tide, right? Please tell me that's high tide.
That's high tide.
Okay, good. Otherwise, I'm like, if that's low tide, then I'm not going in the water. Okay, so that's at 4 a.m. Good thing that's at night. Low tide occurs 7.5 hours later.
So is that 11:30?
I think so. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 11:30. Okay. And it's 18 inches, which is 1.5 feet. This is a good time for me to say that I prefer meters, kilometers to anything imperial. Anyways, I'm going to put the coordinate just because my graph is a sketch and it's not going to look that nice. So I want some extra information kind of floating around. So we have 11.5, comma 1.5. Up here we have 4, comma 8. Right? Cool. I think is 4 plus 7 13? No, it's 11. It's 11. It's 11. Yeah. That's going to live with me forever. No one make fun of me for doing 4 plus 7 is 13. Anyways.
I told my students to give you a hard time, so it's probably going to come back.
I'm excited. I can take it. All right, so we're there. What else can we do?
Well, we know that high tide and low tide are cyclical. So high tide is going to come again, 7.5 hours after 11:30, which is that number 7 p.m.
7 p.m. 7 p.m. So 1900, 12, 13, 14, 15, 16, 17, 18. 19.
That'll be high tide, so back to 8.
Yeah, so we're at 8, and what did I just say, 1900 hours? 7 p.m. Cool. I think we have enough to kind of build a function.
Yep.
We've sketched, we've labeled. Let's draw the curve. Let's use the symmetry of sine and cosine. What's halfway between 4 and 11.5? That's where the calculator starts to come in.
Like 7.75.
This is the part where everyone goes down to the little gear in the YouTube video and hits ×2 on speed. 11.5 plus 4 divided by 2. 7.75. 4, 5, 6, 7.75. So I'm going to put a little tiny dash, 7.75, just so I don't forget. I'm going to put a point right there. How high are we there?
That's halfway between 8 and 1.5.
8 plus 1.5 divided by 2 is 4.75. 1, 2, 3, 4.75. So this is 7.75, not 95, comma 4.75. Right? And then I'm just going to arbitrarily put the next point over here. Once again, this is a sketch. I'm going to draw my cosine graph.
Oh, you gave it a name, you gave it a cosine?
Well, I mean, like, look at it.
Yeah, it's true.
My soul says
Starts
cosine.
up, goes down, goes up again.
All right, so we've sketched and labeled a graph showing the depth of the water as a function of time in hours after 12 a.m. We could, go in all the directions, but we don't necessarily need that because we're about to write a function rule and kind of do some solving. Let's write the function rule. What are you feeling?
Cosine, I
Cosine.
agree. Positive cosine.
Mm-hmm.
It looks like our period is what? 4 minus 19, 15. That makes
15.
sense.
Yeah, and it's like 7.5 times 2, right? 15.
Oh, that's
We had
I
the
think
we
the
had
15
the
is our period.
You're right. You're totally right. So it's our period. So what's the b value?
The b value is 2 pi over 7.
No,
No,
2 pi over 15.
2 pi over 15.
Right? It's 2 pi divided by the period, and to do the other way, we do 2 pi divided by b to get the period. What's our phase shift?
Well, we're starting at 4, so x minus 4.
Yep.
Or I guess t minus 4.
Yeah. T. Vertical shift, not the most pretty number.
7.75? No, 4.75 because it's the
4.7.
midline.
Yeah. I do like the number 47. That's my favorite number. And then we need one last thing, the amplitude,
So
which is kind of annoying to get. It's going to be
3.25?
I'm gonna check, but I'm divided by 2. I did something wrong.
Oh.
Yeah, I don't want the average. I want the distance between them. 8 minus 4.75. And you are right. 3.25. So not the nicest thing, but what we want to do now, Kate's mom will not let her play in the water if the depth exceeds 30 inches. Determine the time during the late morning and early afternoon Kate can play in the water. So 30 inches, I said earlier, was 2.5, right?
Okay, so that's
24.
our y value.
Yeah, 2.5. So I'm going to get a new color. And we need to figure out that intersection point and that intersection point. And that is the period, or not, I shouldn't use the word period. That is the interval where Kate can play. The water does not exceed 30 inches, and it's in the mid-afternoon. How do we do that?
We should probably set up inequality or something. Or I guess we could set that equal to 3.5. No, 2.5.
2.5.
And then solve the same way that we did before. And here, I agree, Mr. Kirk, that we should probably use the U substitution once we get to that.
That's what I'm feeling.
It's very complicated.
2.5. These numbers are not pretty, but I think it's a good exercise to deal with these not pretty numbers. I really do. So let's let's do it.
Cool.
Minus 4.75. 3.25 cosine 2 pi over 15. And I have a request this time.
Mhm.
Let's not approximate any numbers.
Just leave it all.
Cosine to the -1, inverse cosine.
Cool.
And then, by the way, another name for it is arc cosine. I might use that vocabulary term. So we got 2.5 minus 4.75. I'm breaking my calculator out. 2.75 minus
Negative
4.
2.25.
Negative 2.25?
Yep.
Thank you. And then do some division. 2 pi over 15 t minus 4. I forgot the cosine.
Okay.
I didn't forget the cosine. I forgot the cosine in front. Cosine. We're dividing both sides. Negative 2.25
Negative 6.
divided by 3.25.
Negative 0.6923.
Math
stuff.
enter. Negative 9/13. Math enter, by the way, everyone, turns your decimal into a fraction on your
Or in MATLAB, it's format rat.
No.
This is rational. Because I'm low-key using MATLAB.
Right now. Awesome.
Yeah.
All right, so we're here. Let's do that U sub. So let's call this thing 2 pi over 15 t minus 4 is equal to u. And what we want to do is we want to figure out when cosine of an angle is equal to 9/13. When is the x coordinate? Negative 9/13. So if that's -1, then negative 9/13 is like right there. We want to figure out this angle and this angle. Are you getting them? Well, actually, no. We declared that we weren't going to approximate. What I'm going to do is I'm going to say u is equal to the cosine inverse of negative 9/13. And then at the end, when we want that decimal answer, we'll plug this like big thing into the calculator.
Sounds good.
Plus 2 pi k. What do you want to do for the other one? What is this angle? This one up here is cosine inverse of negative 9/13. If you plug that into the calculator, you'll get something between pi over 2 and pi. I want this other one. What do you think we should do?
Is it a pi minus?
Not a pi minus, because this is the identity for sine. Sine is equal to sine theta is equal to sine pi minus theta, but that's not true for cosine. Cosine has a more convenient one. Why did I love cosine so much?
Because it was even.
It was even, which means that the opposite input is going to give me the same thing. Which totally makes sense, right? If I go this way, some amount, if I go the opposite amount, I'm going to get there.
Cool.
And so we got cosine inverse of negative 9/13 plus 2 pi k, and the opposite of that, negative cosine inverse of negative 9/13 plus 2 pi k. So this is going to give us a negative answer, but we can eventually add the period to get the one we want. All right, so I might need to actually add a page. Sorry, everyone, this is turning out to be a longer video than we wanted, but this is tough stuff. So we need to solve the equations. 2 pi over 15 t minus 4 is equal to cosine inverse negative 9/13 plus 2 pi k, and also 2 pi 15 times t minus 4 is equal to negative cosine. And you know what? There's a better way to do this. I'm
there you
plus
go.
Or minus, yeah. If it was sine, I'd probably end up setting up 2 equations because sine doesn't have that plus or minus feature. But for cosine, that's one of the reasons why I like to use cosine functions as often as possible too, because of that beauty with the evenness of cosine. So now we just need to move things around. Multiply both sides by 15 over 2 pi. This will be t minus 4 is equal to plus or minus 15 times cosine inverse negative 9/13 all divided by 2 pi plus 30 over 2, 15K. And if you've done everything right, this will always be the period. Nice little check to make sure that you've been doing everything right this whole time. And then add 4. Plus or minus 15 divided by 2 pi cosine inverse negative 9/13. Are you MATLABing this?
I was, but then I stopped.
All right, so those are our answers. Not pretty. But we can plug this into the calculator. And we get... This is going to take me a second. This is another great place to hit that fast forward button. Maybe I'll edit this out too. It's a quick.
I'm doing it in MATLAB now just because.
You're doing it in MATLAB? You do the positive one, I'll do the negative one.
775 over 139.
Wait, you got it?
Mm-hmm.
7 what?
775 divided by 139.
That sounds not correct. Are you in degree mode?
Oh, how do I check that in MATLAB?
I have absolutely no idea. I'll definitely edit this out.
Or we can just leave it there.
That's fine too, yeah. Yeah, because that sounds like the forbidden word answer. 775, whatever. It sounds very that sounds like this is in that unit and not radians. Negative 15 divided by 2 divided by pi times. Are you currently using the internet to find out how to? It might be something obnoxious, like you have to convert in your code.
No way. No, it automatically does it in radians.
Yeah, because I got something not in the 100s. I got negative 1.575 plus 15K. That's for the negative.
But because what I gave you was a division, so 5.57.
I got 9.576.
Oh, I forgot to add 4. I got the same thing. I just forgot to add 4.
Cool.
That's not bad.
Awesome. Excellent. So we have 9.576, which is way up here. 9.576 is roughly this point right here. 7, 8. My graph isn't perfect, but you know how I fix that? I just move that little tick mark a little bit to the left. 9.576, believe I said. And then what's this other point? So I have 9.576. This is definitely not -1. I think I need to add the 15. So we want 9.576. And I believe it's exceed 30, so we're going to include 9.576 in when she can play. And then what's negative 1.575 plus 15?
13.425.
13.425. What's 0.576 times 60?
34.5.
34. I'll write 30.
35.
I'll write
right?
35, yeah.
Yeah.
And then what's 0.425? Right now, guys, we are converting to time. So this is going to be 1 p.m.
Then 25.5.
26. I'm just trying to.
Well, but at 126, it would be too deep, and then.
Oh, you're right.
Get in
yeah,
trouble.
let's get her out of the water before it exceeds, to prevent any danger risk situations. Whew, there we go. 9:35 a.m. to 1:25 p.m. Kate's mom is responsible. Kate's going to be sad that she can't play in the water for more than a couple hours, but you know what? That's a totally reasonable amount of time to play in the water.
That's fine.
That's about the time I want to be at the beach. Any more than that, I'm like, I'm tired. Let's go home. That's how I feel. Boom. So, there's a lot of white space. I could have probably fit this on one page, but Kami is amazing. You can have infinite pages.
I think at a certain point it'll probably crash, so I wouldn't say it's infinite.
All right. There you go. We wrote sinusoidal function rules, and we were able to solve a real-world situation. Kind of convoluted, but there are many things that behave sinusoidally, as you'll see in lots of examples. I'll try not to give you too many of these tidal problems. Unless you're really into tides, I got lots of tidal problems. But there are many things. Start to think about what can be modeled using something that's periodic. With that said, I think we're good here. Let me stop my share. We had words of wisdom from Miss Sanchez, so we don't need to add any more words of wisdom here. What were her words of wisdom?
Check the bag.
Check the bag. Check the bag. And with that, Mrs. Contreras, do you want to send us out?
Sure. Sounds good. I have a penguin, so it's something to use.